So hello everyone. In the previous sessions, we have discussed about the control flow in the programming, and in that we first studied branching, in which we saw if else, and if elif, etc. And after that, we went what loops, what we call as iterations. In that we studied about for loop, then we studied about while loop. Then we also studied something called as if we want to control the things in the loop. That we said loop control statements. So we were discussing this loop control statements. So these were specific set of keywords which could within the loop, if we write them, so we could somehow control the flow of the loop. So how the loop goes, so we can control that. So in that, the first thing that we studied was break, and then we studied continue. I think we had a good discussion on these two things. Now I actually told you that there are four statements like this. The first statement of break, then continue, and then we have this pass and else with these loops. So we can else write else with the for loop and else with the while loop. Okay, let's see that first. Let's see the pass. These things are specific to Python programming, but if you see this loop control statement, this is the concept. This implies to every programming language. So whatever programming language you program in, it may be C, it may be C++, it may be, let's suppose, Java. So all these things will apply. But now, depending on how the designer of these languages have designed the things, they might have added some things, they might have probably subtracted some things. There may be some things missing which are in the another language. So if you see in Python, so we have these four loop control statements. So we had a detailed discussion on the break and the continue. Now what we want to do is we want to have a discussion on this pass. So in the pass, what we want to do is, let's suppose you are writing some. This pass is not just for the loop control. So you can use it in many ways. The first thing is, let's suppose you are defining something. So you're writing a program and you don't know what to write that, but you still want your program to run somehow. Let's say you want to write some code. Let's suppose this is a function. We will go to the functions and you want to write something, but at right now you don't have any clue. So you say, okay, I will write this function later, but if I write the incomplete syntax, you know that I'll get a syntax error. So the better part is that you can just write pass in the body, because probably sometimes you don't have a clue what to write. So in that sense, what you can do is you can write pass. That's one of the functionalities of the pass. Okay. So what I mean by pass is that you can just take, for example, a code, and you have, if you have no idea, or maybe let's suppose you want to implement it in the future, so you'll just write the pass statement over here. What pass does is, it won't give you the syntax error, and it will give you some placeholders. It will give you some instead of writing this comments in the code or something like that, it is better to write the pass. You might have seen in many, if you search in a huge code base, and they'll write some functions. In that, either they'll write not implemented yet, raise error, or maybe they'll write pass. Pass basically means this should not give me the syntax error. Okay, now let's see it how to use in the loops. I have some examples for you. Just give me some seconds so that I'll pop up those examples. Okay, now let's directly go to the code and let me show you that. Let's suppose this is my VS Code, and here what I'll do is I'll just write a new file, because this is session 9 in Python, and we'll write code test.py. That's the first file that we'll have. I think you can see the screen. What pass means is, pass basically means do nothing. So if I write it like this, so I can write pass means do nothing. So pass is equivalent to do nothing. Okay. Or why is it used for? Because I said probably you might be having some idea in the mind and it's not yet concrete. You want to write something, but you are not yet decided what I want to do that. But you don't want to have this syntax error. If you just write something and you let's suppose have the syntax error, as I showed you the example of this a function. If you want to write a function, you write a function, and then if you don't have an idea still what I'm going to write, or maybe you will modify things further, so you just write this pass. Okay, let's do with the if let's suppose we can write it with if also. So if something is there, okay, then I don't know what I'll do, but still I'll just pass it right now. So right now I'll just write the pass. Okay, so let's go back to the code, but I believe it should be visible, but it's not somehow. Are there two windows? Yes. So are you able to see the things that I write on the screen on this visual code? So what I was telling you is that if we write a statement like this, so I will write, let's suppose, if there's a condition, so what I can do is I'll write, let's suppose a is equal 10. Okay, and I'll write if a is greater than 20. So I want to do something, but right now I'm not sure what I'll do. So what I'll do is I'll write pass statement. So this will not give me any error. So if I don't write anything in this loop, let's suppose, and I'll keep it like this, so I'll have probably no idea, okay, what will pass do. So that's the reason I say pass means do nothing right now. So do nothing, but probably later I'll come and I'll write the functionalities there. So if I just write this code, if I just run this code over here, and I'll write Python test.py, that's how we run the code. You can see, oh no, Python, and the name of the file is test.py. So nothing appeared on the screen. That's what I mean by do nothing. So this pass can be now use the loops. So let's suppose we are writing a loop. So we'll write a loop for I, write a loop for which iterates the things at 5 times for I in range 5. Okay, so if I just print this thing, it'll I can do a lot of things. I can do a lot of things in 5 iterations. So what I'll say if I is equal to 1. So for that pass means do nothing. Probably I have to decide later on what I'll do is. And otherwise, what you can do is else print I. This is the code I want to write. And here I'll just comment this code. Pass basically means do nothing. Why am I showing you all these syntax? Because when you read that huge database of the code, when you have this huge code base, so there you will see frequently people adding these pass statements. Because as you know that when you work on an idea, this idea is not fully grown at that time. So you slowly and slowly get to know about, okay, this is the thing that I want to implement, and this is the thing I don't want to implement. So that's why you do these, you write these statements. But instead of just having a code or interface, you'll just write these pass statements. So maybe it tells you, okay, if I want to do nothing here right now, I won't do it. And rather, if I at the later stage of the program I want to do something, I'll just come back and remove this pass statement and do something. So now I'll write do nothing. Now if I run this line of code, so you can just clearly see that 0, 1 was skipped, okay, and we did nothing on the 1 because if this condition was met, pass the code, and we want to do, and we don't want to do anything. But otherwise, if it's not 1, then do something. Okay, I hope this is clear. This pass is not just used in the loops. This is also used in functions. This is also used in, let's suppose, classes if you want to do something. And this has a lot more functionality than this. But I gave you a bigger idea. But the idea is that if you don't have a concrete idea and you are yet to decide what I want to write within some function, or maybe if a condition is met, so you'll just write this pass function. So later on, if you come, you can just remove this pass statement and add the code lines accordingly. I hope this is clear. I'll just pause here for a second. If you have some questions, I'm ready to take that. So and the example that I'll show just for the sake of completion here. So I'll just paste some code. So if you see, let's suppose this A is a string which contains AIMLDL. Okay, I hope this is visible. Yes, it is. So what I have done is I have initiated this I is equal 0. Okay, and then what I have done is I have said while I length is length of A, and you want to just check the condition, you want to run the loop these many times. Okay, but what I am doing is I am writing I plus 1 and pass, because I am not doing anything in the loop. I am just running this loop the number of times, okay, this number of times, the length of A times, and that's why I am named this empty loop. And this is why am I showing you this, because this sometimes becomes very important, and you want to run an empty loop because you don't know why will you use it, because now you are sure that I have to iterate over this string, but you don't know what I have to do with the string. So that's why it'll get you useful. And even if you see this counter value is getting changed, but you don't, it's just an empty loop. You're looping over it because you just want to iterate this iterate over the I, and you want to increment its value, but you don't want to do any specific thing. That's why I've just written the password here. So if I just print this one again, you can see this value of I is 6, because the loop ran 6 times. It initialized with 0, and then the loop ran 6 times, and we got the value 6 over here, because this, if you see, this is 1 2 3 4 5 6, we have 6 letters in that. Okay, and let's suppose one example can be, if you just want to check, let's suppose sometimes you want to run something for 6 number of times based on the length of the string. Okay, but you don't want to do any specific thing within the loop, and you want to just keep the counter over there. So that's one of the example where you can use this. But pass specifically has the function do nothing, and later on I'll maybe modify the code. Okay, now let's see with this, what is this else for. We have this else with the for loop and else with the while loop. Just closing out the screen. So now we'll see this else. So we have so far seen what break does, we have so far seen what continue does, and we have also seen what this pass does. And then we have this else statement, else with loops. Okay, so this is again Pythonic. So you won't probably see it in any other language like C, C++, Java, because they don't have else with this a loop. So here in Python they have given else with the loop. Okay, and it's a design choice. By design, if you ask me the question why have they given it, they might have specific reasons. Okay, but it is sometimes also useful. If you want to do something, it is sometimes useful. So how was the syntax? So you'll write the loop, and at the end you'll also write else. Okay, so let me just show you a code snippet, and then we'll dissect the code so that you understand it better. So again, bringing up the VS Code over here. So I'll comment out this code. So if you see this, what I have done is I have written a loop, and then I'm saying print I. So I'm saying if I is equal to 3, then break the loop at I is equal to 1. That is break the loop at this time when I is equal to 3. Okay, else the loop is successfully completed. So just run this program and understand what is done. So what I have done is this is writing 0, 1, 2, 3, and then breaking the loop at I, and then it is not printing the else. So if you see, what this tells you is that else statement only gets executed if the loop is not broken. Okay, so if the loop is not broken by this break statement, okay, if the loop is not rather terminated by this break statement. So let's suppose if we did not have this break, let's say if we did not have this break. Okay, so now if I run this code, you can see this 0, 1, 2, 3, 4, the loop was completed successfully. So now if you see, if you tell me, ask me what is the design choice at this, sometimes you want to see if the loop was terminated by not doing all the iterations. So this else becomes important there. Okay, sometimes there are things, let's suppose you are reading a lot of files in that, and you know that for certain things the loop will terminate by this break statement, or some it will not. But now you want to see for what files this loop will not terminate. So you can write that code in the else block, and for the things where this got successfully executed, you want to do certain things. Okay, on that you can do with this else block. So what's the functionality of else? So else will be executed only if the loop is not terminated by this break statement. Okay, I'll probably write it somewhere. So else will be executed only if loop is not terminated by break. So if the loop runs successfully, and at the end you want to be sure that loop ran successfully without having this break statement, so then that's else. And as I showed you with the example, so here when I had a break statement, if I use a break, the else won't get executed. This is again a purely design choice. Some people might disagree. Oh, I wanted this else to work like this if the loop got broken, and then we should have this else for that. But it's totally design choice the programmers. If you see this 0, 1, 2, 3, and then we had breaking at I is equal to 3, so then else did not get printed. So once I remove these things, so once I remove this break from here, I don't want to break the loop on certain conditions. So if I run now this, so you can see this, I have not saved this. So if I run this now, you can see this, the else gets executed only if the loop is successfully executed. I hope this is clear. Any questions over here? Then you can ask the question. The question should be, okay, why do these inventors or designers make these specific design choices? Okay, the answer is very subjective, because if I am a designer, I'll probably have my own biases with me. If I am designing a language, so I'll have my own theory and my own philosophy of designing a language. So that's why I'll keep on adding these features. Okay, and but this has a practical implementation. As I just gave you an example of the files. So if you are reading something, and sometimes you have a loop, and you know this program gets executed multiple times, and you have a break statement in there. So if this statement is terminated, so you don't want to do anything. But if this loop is successfully executed, so you want to do a certain thing. That's what this else makes sense in there. Okay, so I hope this is clear now. So again, you can have the same thing with this while loop. Let's say we have a while like this. So let me comment out this code. But this is only specific to Python. This else with the loops is only specific to Python. So what I'm doing is I'm writing I is equal to 0 while I is less than 4, increment the I, and then print this I, and only print this else if there is no break statement. If there is a break statement, you know that this won't get executed. So if I just run this code, so you can see this 1, 2, 3, 4, there is no break. But if I on purpose put a break, let's suppose if I is equal to 2, so I'll break. Now you can be sure that this else won't get executed. Okay, you can see 1 and 2. At 2 I broke and I terminated the loop. Then this else block had no choice, because we're coming out of the loop, this else won't get executed. Okay, I hope this else, the functionality of this else is clear. Are there any questions on this? Now, if you see that we have studied these four loop control statements in which we can have a control that we can control how the loops work. And there was a question by Arshan that can we use this continue instead of pass? Continue has a specific function. So in continue, what you do is skip a thing. Okay, in here you don't want to do, in pass you don't want to do anything. So pass means do nothing. Continue, you want to just keep on running the loop but do nothing. But if you see this, if I just showed you one example, if and continue, there seems like they have the same functionality. But if you can use this pass with other things as well. Okay, but in continue you can just use continue the conditionals, but this pass can be used within the functions, and you can use as I showed you in the while loop also. It can be used in a different ways. Okay, when you don't have an idea what I want to implement right now, because maybe in the later stage of the development I'll just decide what to do. So you just write these pass statements in the Python programming language. So if you read these big code bases and where people have written some huge projects, so there you will frequently see people writing these pass statements. So that was one of the reasons I introduced pass, so that you don't get confused. Okay, why is this pass used for? Then one of the interesting concepts is called as Sentinel control statements. So within loops we use that. So that's called as Sentinel, or Sentinel rather, Sentinel control statements. So what are these things? So let's suppose sometimes you don't know when a condition will get met. Okay, so you want to break the loop if a certain thing is done by a user. Let's suppose. Okay, let's suppose you might have seen in this, if you many of you program in, let's suppose in Linux. So there you will see press Y or press N or something like. Otherwise you will keep on looping something. So what is the meaning of Sentinel? We don't basically use any counter variable. So usually we have these counter variables. If that is space less than this, and then break the loop. So here, if you don't know how many times the loop will run, and you only decide that thing, so you'll put a sentinel. Let's suppose if the user presses this key, break the loop, or if user does this, if a user does particular thing, or if a program does, but it's not only for the user. If a program, if a variable gets some, let's suppose some value in that, and you want to break that loop, and that's what is called a sentinel control statement. So in that you will just write a statement, and if that condition is met that time, okay, since if it's not met, you will keep on doing that. Let's directly go to the code and we'll see what is the meaning of that, so that you get a better hang of this concept. Okay, now what I'll do is I'll just create a new file, save this file over here, create a new file, code test1.py. Now I have this file over here, save it. So let's suppose what I want to do is, so if you can see over here the code, so I've written a, enter a number, and -1 to quit. And you might have seen it in a lot of the terminals. So if you work with the terminals, you will see press this or this to quit, or press Y for yes and press N for no, something like this. So what I have done is, if while I is not equal to a, keep on getting a number and keep on printing that number. Or maybe let's suppose I'm just printing a number, I can just do one thing, and I can just a multiplied by 2, something like this. So till I don't enter this -1 to quit, it will keep on popping me this thing up. Okay, so let's just see this in the code, and this is should be Python test.1. So now enter number or 1 to quit. So if I just number 2, it'll get multiplied by 2. So I got so here I did not get, I should basically get printed this statement. Is it printed somewhere? Let's see, I'll write -1. Yes, it's printing after this. Let us do one thing, we'll write the print statement. That's what I said. Why do you print? It becomes important. Why do you print these things? Okay, so it's better to print first and then do it. So now if I do the same thing, Python test.1, there are 2. So it's giving me output as 4, then again telling me enter a number. Let's suppose I want 6 multiplied by 2. So 6 multiplied by 2 is 12, enter a number or -1 to quit. When I enter this -1, so what will happen is the program is terminated. So this over here, if you see this a is not equal to -1, this is called as sentinel. Why is it called sentinel? Because if this condition is met, then only we'll quit. Okay, that's why if you have if you are doing bash scripting or something, so when you write these scripts, so frequently use these sentinel control statements. You will ask user, okay, if you want to quit, press this. Otherwise, if you want to keep on doing this, or you don't need to press -1, and other than that, you can press any key. Okay, and if you want to do have this loop forever, and but on a certain statement, if a user does that, if a user presses that key, you just want to do one thing, you just want to quit the loop, or you just want to come out of the loop. So this is the example of the sentinel control statements. Is there a question in here? Any questions? Okay, So now let's see some examples of why these loops are used. Okay, well, I'll show you some basic examples why these loops are used, so that you'll get some hang of this, and then we'll go to the advanced looping concepts. Okay, so let's suppose you sometimes want to keep a countdown timer. Okay, usually let's suppose if you are making a bomb, let's suppose, and in that you want to do a countdown timer. So what you can do is, so you'll basically use these loops to run that. Let's suppose we have this countdown 10 till the countdown is greater than 0. So keep on printing countdown and then decrement the count. So you can see this. So let's suppose you have this meter set at 10. So what you can do is it'll wait for 10 seconds, and this countdown can be for seconds or for hours, howsoever you want it. But internally what it'll do is after each hour it will just decrement the counter by 1, and after 10 hours it will blast off. So that's one of the examples why this loop is used. So just running this, so you can see this 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and blast off. That's one of the example. And now this also is used. Let's suppose if you you might have seen this login screens many of the times. So there you have database in the backend, and you want to check for the passwords. Okay, if the password that you have written is correct. So you also use these loops there. Okay? Let's suppose what you are asking is, you are asking for the password like this. So let's suppose your actual password is secure123. This is your actual password. So it will be somewhere stored in the database. Okay. So when you are popped with a login screen, there you will see that, okay, login with your username and the password, and that password is somehow stored somewhere in those servers, big servers. Let's suppose you are trying to access Facebook, so they'll have your password somewhere stored, and these passwords are stored in a cryptic form. So first they'll have to decrypt it, and then the simple line of code they'll write is, so they'll put that thing in the infinite loop. So they'll ask user to input the password. Okay. If the user password and the password that database they match, then they'll give the access will be granted. Okay, and this loop will break, and then it'll go give you the new screen. Let's suppose in the Facebook it'll give you the new screen, or in the app it'll give you something else. Whatever it'll say, access denied, try again. It'll keep on giving you this. So let's just run this. So if you see, many other web developers, they won't be probably using it. They don't write this much code, because they have already these frameworks are there. So they just import these things, but it's necessary to know internally how the workings are done. And this is just a simplistic example. So I'm just writing this Python test, enter the password. Let's suppose I wrote the wrong password. It will be ABC, something like this. So if you now see, it is access denied, try again. It will keep on popping me, enter the password. So now you can again put a counter over here. If the password exceeds 3 times, okay, then block the account, and something like that. So you just have to keep on adding this code right here. So you see access denied, try again, enter the password. If I now put, let's suppose again a wrong password, CBA, something like this. So access denied, try again. Now if I write right password, secure 123. Now you can see this access granted. Okay, now I'll show you the way to block the account. If you want to block this account, let's suppose, so you'll keep a counter over here. You will say count is equal to 0. Initially the counter was 0. So when the user input the password, okay, what you can do is, so you can just put count plus is equal to 1. Okay, you will increase the counter. So here, let's suppose if the counter became greater than, let's suppose 3, you want to block the account. So what you can do is, you can say if count is greater than or equal to 3, or maybe greater than 2 rather. So what you can do is, you can just print account blocked, something like this. So I'll write account blocked. I'm just writing this print statements, but this, instead of this print statement, there will be a huge bunch of code which will block the account, and these blocking of the account will have specific code for that. But here, assume that this print is there to block the account. So now if I run this code, let's suppose now if I run this code, enter the password, I'll write ABC. This is wrong password. Try again. I'll write CBA. Okay. Now I have done it. Like I have blocked the account on 2 tries. Okay. If I want it to be, let's suppose I want the code to get blocked at 3, you can just change this statement at 3 so that this account will be blocked. Okay. So everybody clear with this? Are you clear on this? Okay, so this was and the example of where we basically show you this. If you are building some secure system, so this has different mechanism though. I'll just take a digression to explain the mechanism a little bit, so that you know in the real world how it is done. So this password, and Facebook actually did a mistake. I think a couple of years back, they have stored this password as plain text. Okay, then somebody got access to their password servers, and whole of these passwords, there's a whole of breach. And if you just search on the Google the breach that have been done, and sometimes you might have received emails from Google, okay, your password is compromised, because what actually happens is this public databases, okay, they are basically public uses it. So if they store it into plain text, so if some discrepancy happens and somehow we got access to these passwords, so whole of these passwords get leaked, and then your account becomes no longer secure. Probably people might try that, okay. And the third and the second point, important point, is that's these companies are then penalized heavily. So what they have done is they'll implement some cryptographic protocol. So what can they do is, so instead of securing your password like this, they encrypt your password and store it somewhere, okay. So what they have done is, so if let's suppose now if they have to get check the password is same, they won't check it just like this. They won't just get the password in plain text, and they have to decrypt the password first, okay. And while decrypting also, people might like do some eavesdropping, and there are a lot of mechanisms by which you can be ensured that even Facebook does not know your password, okay. That's sometimes called as end-to-end encryption, which you might have seen on Facebook. And there are a lot of mechanisms now introduced, so that even the parties that hold these passwords, they are not able to decrypt it, because now you have a private key with you, so that these things are not decrypted without your permission, okay. But that's again a huge, what I can say is just some sugar coated things, but they more or less know all these things, so if they want to, okay. And that's why one of the reason. And recently Indian government was asking for these big companies, we should get access to the source of these. Like suppose somebody tweeted a thing, so if it is a rumor, and and now it's spread it a lot, and then people got to know that this was actually a rumor, is not a right news. So they wanted these companies to give us the source, but companies were not willing to compromise the users, okay. And then there was a huge debate on this: should even we leak the privacy of the users, then what's anonymity and the things like that. But you should be sure that how coders do it, okay. This is a simplistic code, but the basic block will be like this. And after that, what will happen is, if you want to do something, so I said, I just wrote print statement over here, print statement, account got blocked, something like this. So if I wrote something like this, so rather than this, what will happen is they'll write a huge bunch of code, okay. What do I mean by blocking? By blocking, I mean next time if they come, they should not be able to do it. And that's the reason these blocking account is not mathematical proof, they are just software hacks, okay. Just remember that there are difference. So if your account gets blocked, it doesn't mean that you can't recover it, okay. So if you know if you know the mechanism of blocking, if you know how the account got blocked, okay, why was my account blocked, and what can I do? You can navigate this code, because more or less the knowledge that I have, at least, these are not like mathematical functions which they have given proofs of. Okay, this is the account is blocked, now you won't be able to access, and there's a mathematical proof. No, they're just software hacks. So that this gives me a chance to explain you an important concept, that is the software difference between software hacks and mathematical proofs. Okay, so what is a software hack? Let's suppose you want to do a certain thing, okay, and you want to achieve it, and for that you will just use a software patch. You will probably write some code, and you will do that. But you know that if somebody just know your code, and he can just bypass this, if he bypasses this, okay, if he bypasses this, so then it's a software hack. So till the people know this, you probably are just in the right place, and once the people get to know, they'll bypass this thing. That's why each time you will see these apps are getting updates, because they find some security breach. And because why? Because they are not mathematically well grounded, because there is no mathematical proof that this will work. So they'll just have this rather than this software hacks. What is a mathematical proof? And if you have to prove something is secure, you have to prove actually something is a perfectly secure, you have to prove its perfect secrecy, okay, mathematically. If you proved something mathematically it's perfect, okay, then you implement it. Then no matter how much software hacks you use, you cannot probably break it, okay, because it's perfectly secure. So just giving you an example. So recently we had a problem like this. Just taking a detour so that you also find these things are interesting. Yeah, we're not just reading it for the reading purpose. So we had a problem like this. I'll just mask the company names. So we had a company, let's suppose I'll call it company A, and we had some company B. Okay, everybody with me? Show me the reaction so that I can give you this case study. Yes. So there was this company A and there was this company B. This company A was basically making 3D designs. Okay, so they were making 3D designs, and this was of weapons. And now they have to 3D print it. These are prototypes, and they want to get it 3D printed. But if you see, this company B had these industry grade 3D printers. So they had industry grade 3D printers. So if you see this, these are very costly, and academic institutions and small companies, they cannot afford to have this. Okay, so now what they have to do is, this company A had to send this design to company B. So they had to send this design to company B, and company B will get printed. But these parties were what's called as mistrusting parties. So they were mistrusting. Mistrusting basically means they do not trust each other. Okay, so A will probably send designs, but they don't know B will copy the designs. Okay, and B can utilize it for their own code. Okay, that's the first problem that way. If you see now, the first problem was you should securely transmit this kind. You should securely transmit the files from A to B. That is the first thing, because any of the eavesdrops in the middle, they can have what's called as man the middle attacks, and they can get the access to the files. That was the first problem. The second problem was while decrypting the file, because these people are decrypting the file and they'll have encrypted version of the file. This company B will decrypt. They should not somehow know. Okay, this thing, once they are printing the file, they should not somehow even get the access to the original file. That's the problem setting. Okay, if you see, the first thing that was to be solved was this securely transmit, and they wanted it to be quantum safe. Because right now the algorithm that we are using for transmit is called the RSA algorithm, and the whole of this RSA is grounded in the thing that's called as discrete log problem, or we call it this prime factorization. In simple terms, I'll say prime factorization is hard to solve. Okay, if you have a prime number, huge prime, if you have a number and you want to break into two prime factors, it's hard. So these are called as one-way functions. So if you have a number A multiplied by B and you get number C, so A multiplied by B it's easy to do. Okay, but if you want to get C, this C is basically equal to A multiplied by B. If you want to get A and B out of the C, this is hard. Okay, that's whole of this algorithm is based on this RSA algorithm is based on this factoring problem. So factoring problem is hard to solve for these classical computers. And now there is an algorithm called a Shor's algorithm. So Shor's algorithm gives the guarantee that if we have these quantum computers, you can break this RSA crypto system. So that is the first problem we had to solve, that if you are transmitting file from A to B, they should get securely transmitted. And you can give a mathematical proof for this. You can give a mathematical proof that if you have an unbound adversary, and you can be sure that if even he got access to the encrypted file, he won't be able to decrypt with the quantum computer 7. That's the first problem. This problem is easy to solve. And now the second problem that we had, okay, if this company B had the encrypted file, now they'll have to decrypt in order to print it. So in order to get the prototype done, because they have the file and they want to print the prototype, but they didn't want to give the B access. We could have applied software hacks here. Okay, once you just get the access to the file, just delete the file out. We can write the code, self-destructing code. But that's again a software hack. Once the company gets to know that, okay, once we execute this certain set of commands, so they are deleting the files. So what they can do is they can write some other code so that the file does not get deleted. And then once we get to know this, and we can write some other code. All of these will be software hacks. Okay, and then we try to argue mathematically. Can we come up with a mathematical function? Can we come up with something well mathematically grounded, so that if we have this file, if the B decrypts the file, at the same time they should not be able to get the access. And then we came up with a solution that's called as multi-party computation. We should have multiple parties which might be mistrusting, and will what's called as secret sharing. Will secretly share the files, and that is mathematically well grounded. But did you understood where are these things? I just went from loops to here so that you just have a connection, that we are not just reading them for reading sake, and they have real world applications. And you should not always believe in these software hacks. Okay, you write some code, you give a patch. That's why they're called patches. Okay, you might have heard that this is a software patch. Why? Because they know it's not mathematically well grounded, and it can be broken by any way. If people got to know, they'll just come with some clever tricks, and they'll just find some other ways. That's why they give patch again. Okay, because they are not mathematically well grounded. But if you are writing very sensitive code, it should be mathematically well grounded. It should have a mathematical proof. Any questions on this detour? Now what we'll see is we'll see how to find a factorial. Find a factorial. Really easy. Most of you have done it, but I just want you to see how to think. Okay, how to think about this. So find a factorial. So I know that this is solved by the loops. There are two ways now. The first thing is you can just go on some online blogs, and you can just copy paste the code and just write it. Otherwise, you can think through a framework. You can think, okay, how do I know this loops now? Okay, I know how to take input. I know how to perform operations. But now the point is how to think of the factorial. Okay, let's make this first clear. Okay, what is a factorial? So the factorial, in mathematics, if you have suppose 4 factorial, is doing something like this: 4 multiplied by 3 multiplied by 2 multiplied by 1. This is definition of factorial. So you're doing 4 multiplied by 3 multiplied by 2 multiplied by 1. So now you are seeing the repeating thing. What is the repeating? The repeating thing is operation. You are multiplying continuously. Okay, so now we saw that, okay, there's a repeating pattern. So if you somehow see this, there is some repetition. It can be a repetition of operation, it can be a repetition of statements. So if you see this, the bell should ring in your head. Oh, I can use the loops for this. Okay, so what I can do is, now let's write the pseudo code for it. Okay, what I want to do. So I want to find a factorial of what number. So the first step should be, ask a number, take a number from user, ask user a number, user to give a number. That's the first step. Okay, how to think through. After that, how to now do this factorial. So now the pseudocode is, now let's suppose if I want to do is, so what I can do is I'll take this number, whatever this number, let's call this number n. So I'll decrement one by one. So I'll have this number, let's suppose n. So I know that let's suppose it's 4. So if you see, this loop will run 4 times, 1, 2, 3 and 4 times. If the number is, let's suppose 10, you know, 10, 8, 9, then 7, 6, 5, 4, 3, 2, 1. So this will again run 10 times. So now you know that I'll have to run this loop the number of times this number basically. So what I can do is I can use a while loop. While this n is there, while this n is let's suppose this n is greater than 0, let's suppose. Once it gets to 0, because you don't want to do anything. So if this number is greater than 0, so what you want to do is, you'll probably do some multiplication, but you'll have to now store the factorial. So how can you do that? You say factorial is equal to initialize value 1, because you know that 0 factorial is 1. If somebody give you the number 0, so for that 0 factorial is 1. You know that for any number, because factorial is not defined for negative numbers. You should be clear on that also. Factorial is not defined for negative numbers. And now you know that number should be 0. Okay, once that number is given to you, okay, 0 factorial, the factorial that should be is 1 by default. Now you are saying that while n is greater than 0. So what you can do is, you can say factorial is equal factorial multiplied by this n, and then decrement the number. Okay, decrement this number by 1. I'm just writing the pseudo code. Okay, now you have to make sure that user also gives you the positive number. User should not give you the negative number. That's why you can use these loop first. Once you ask for the input, in that you should basically take only the positive numbers, included 0, and then you write this code. And let's write this code and see how the problem is done. I'm just giving this very easy problem to solve. I know most of you have done it, but just want you to give how to think basically. Okay, now let's comment out this code again, and I'll just write, let's say, code test.2. Now here we have second file. So the first thing is, I want to take input from the user. That's the first thing that I want to do, take the input from the user. So how to do that? So I'll probably have a number, int, take input, enter a positive number, enter a positive number, or rather I can say non-negative number, include 0. Now you know that this should be non-negative. So what you can do is, you can put the whole thing in the while loop. So whole of this should be in the while loop. So I'll write while, and this is infinite loop. While number will take this, and then you will only break this loop if the number is positive. If number is greater than or equal to 0, then only break. Otherwise, keep on popping it. So this is the first step I did. Number is greater or equal to, I just wrote by mistake. Okay, now let's just test out this code. I'll test this thing. I'm not just showing you the things. So I told you that you should be good at debugging also. So I wrote this amount of code because I expect a certain behavior from these lines of code. Now I'll check the behavior. So I'll just run this code. Okay, now you enter a positive number. If let's suppose by mistake I wrote negative -6, enter a positive number. Let's suppose -8. Okay, enter a positive number. I'll now, let's suppose, say 12. Yes. Now the code, this at least till this, the code runs as expected, the way I want it to be. Now what I said is, you have to compute the factorial. So how to compute the factorial? I give you the logic. Let me just paste this so that we save the time. So this is another thing. So what I'll do is, I'll say factorial is equal to 1, and this number, I'll call it num, and this is number over here, this is number over here. So what I'm doing is, this factorial is by default 1 now, because I know that for 0 factorial, the least number that I'll expect is 0. For that, this is the base case. Okay, factorial is equal to 1. Then what I'm doing is, till the number is greater than 0, keep on multiplying this number with the factorial that we originally have, and then within each iteration, subtract it by 1. Okay, and then print the factorial at the end. Just let's run this, and I want to factorial of 4. You can see factorial of 4 is 24. And now again run this file. Now if I give negative number, I know this should again pop me up, print a positive number. I'll give 0, so 0 factorial is 1. So everybody clear with this? Okay. So I would have loved to show you more examples, but I'll probably do that with the assignments. I'll give you assignments where you'll on yourself try and test out different examples. But here I just showed you some few examples where you can just try out these things and see how people code. Okay, The one thing that I showed here is first do not just go to the coding screen and do it. Just understand the problem first and try to write the pseudo code. Okay, how I want to achieve this. And after that, once you are writing the code, you write these simple snippets of code and parallelly try to basically test them if they are behaving as expected. Okay. And now let's go to some advanced looping techniques that Python provides. Okay. So I named them as advanced looping techniques. Advanced looping techniques. Okay, so this again is specific to the Python. So if you ask me, are these functionalities available in other language? Probably maybe or probably may not be. So, but you should know them so that if you are using some other language, you can also recreate these functionalities. So Python basically offers a lot of techniques with inbuilt functions. Okay, they are let's suppose if you are doing competitive programming or doing some diverse projects and you want your project to like sort of hasten up, you want to code fast and you don't want to write a humongous lines of code, and Python provides with lot of these things, a lot of these advanced looping mechanisms. The first thing that I'll do is, so I'll use this function called as enumerate. So within the loop, sometimes what you want to do is you also want you want two things. You want index and the element. Let me give you an example. Many the times, if you people have coded, so you know that sometimes you really want to do that. We really want to have an index and this element also. Suppose we have a list in which we have some names. Let's suppose ABC, DEF, GHI, something like this. And now I want each the element also, but I also want the index that they are present at. Or let's suppose I have a bunch of students, like I have students Mahmood, we have Anwar, Liaquat, and these students are there. And now I want to print these students based on their rank or based on the grades they got, based on the rank they got in the class. So I just want their index also. Okay, let's do that. And for that, we'll use this enumerate function. Let's go to the code and let's do that. Okay, so what I can do is I can just write students. This is a list. Let's call this list. I'll write Mahmood, Ijaz, and we have Ali over here. Maybe let's say we have only these three students. And now what I want to do is I want to get their index as well as the value. So what is the thing is? So I'll write for index, comma. So now I'll get index and student in. And now I won't just write student, so I'll enumerate these things. So I'll write enumerate. And what I'll enumerate these students. So enumerate function basically gives me the index as well as the student. Now I have a hold of this, so I can print out these things. So print. So I'll print the index, comma the student. Okay, now if you just see this, Python test.2. So you'll see this 0, Mahmood 1, but 0 doesn't make sense. So what I can do, we can just do +1. So 1 Mahmood, 2 Ejaz, 3 Ali. Okay, here I got the access to index as well as the student. So this is achieved by using this functionality enumerate. Okay, you want to index and as well as the value that is there. Okay, that's first. I'll just comment this. So this is enumerate function. Okay, there's another function. So let's suppose now we want to iterate on two things simultaneously. Let's suppose you have let's suppose two files. So what I can do is now I have these students. I have this Mahmood, Ijaz, and Ali, and I have their age also. I'll on purpose write the age as bigger number because I don't want to offend somebody. I'll write 100, 150, and maybe Ali I'll write 200. Okay. Now you know that I have two lists right now. So what I want to do is in the single loop. What I want to do is within the single loop, I basically want to somehow merge this. Mahmood has age 100, and Ejaz has age 150. Ali has age 200. Okay, so for that, what I will do is I'll just comment out this much of code, this loop which I use for enumerate. So there is a functionality called as zip. So I can zip these two things together. Okay, so what I can do is, so let's just paste these lines of code so that it becomes easy. Okay, there is this function zip. So here I have students now. And then these names I have students. This is hash zip. This is zip is in the function. So what zip basically does is it will basically put these two things together. If you want to just see it, so what you can do is you can, before even doing this, you can see what zip does. So you can just take this line of the code over here. You can just print zip. Oh, sorry. and we want to see what it does. So just run this. So now if you see zip again is an object, it's printing an object. Okay. So this is the internal functionalities. So there is a way to like print what is there. So I don't want to get into those because you don't know right now. I don't expect you to know object-oriented programming. So now let's unzip this. Let's uncomment it rather. So if you see for name and age, so what this is, so it will take the first element and assign it to the name. It will take first element of this age assign the age, and accordingly it will do within the all iterations. So for name here, you can see we don't write this, we don't write any range or we don't write any list. So we are using this zip function. Zip basically will take these two things together, and for the first element, it will take it from students. Basically for the first value rather, it will take it from students, and for the second value, it will take it from age. So now if I want to print it, you can see. So name Mahmood, age 100. Name Ijaz, age 150. Name Ali, age 200. So this is, and the functionality, we can use this zip. So now you saw two things. The first thing that you saw is enumerate. Enumerate basically if you want an index and if you want the value also. The second thing we saw is zip. If you have these multiple, you can also zip three things together. Okay, let's suppose I'll just have what I can say, qualifications, QUAL qualifications. You can probably write over here, masters, say. Okay, and then say PhD. Let's say I'll write UG. Totally random. So I can zip these three things together. So now I can put qualification also over here. And I'll put this Q and I'll say name is this name, comma age is this age, comma qualification is Q. So now if I print this again, it will zip all these things together. Now you see name Mahmood, age 100, qualification masters, and this is how you can do the iteration on multiple things together. And you know that sometimes files are stored in different. You have one file but that they have relation within each other, and this is very practical. So that's the amazing thing about Python is that when the developers were developing these things and when they were giving additional functionality, they kept in the view, okay, what is actually being used in the real world. So this, all the thing will be, you probably will use this in the backend. So you will have multiple relations. If you are working with this relational database, there you will have multiple tables. Now you will have to take some data from one table, take some data from, consider these as different files, let's suppose. This is one file, this is second file, this is third file. But now you know there is a relation within these files. So if you have this loop mechanism, zip, you can zip all of these together and then you can just take the values. How, like, you see how they respect the philosophy. The philosophy of the coding is the ease of programming. I hope that this zip is clear. Any questions regarding this? I'll just pause here for a second or so. Now you have seen, like, we have at least seen two other things. We saw enumerate and then we saw zip. And there is one more important thing that's called as list comprehensions. List comprehensions. Okay, what are these list comprehensions? So now if you see in the day-to-day life, so if you are coding a lot, so sometimes what you just need a list. Okay, in that list you want to, let's suppose, initialize some elements. Say you want squares of numbers. So what you can do is, so you have a list and in that you want squares of squares of 100 numbers. So there is one way. One way is write a big loop. So you can write while this and keep on appending the things. Okay, and it's a bit tedious. Now if you see, design philosophy of Python is ease of programming. So what there is, and he was a mathematician. Two things you can remember in the mind. So the guy who invented this, his philosophy was it should be very easy for programmers to code. And second thing is he was a mathematician. He'll somehow put the mathematical things in here. So now what it is, what the initial inventors of Python did is they said we'll put these list comprehensions. Sometimes you just need to initialize a list. In the list you just want some elements. So they come with these list comprehensions. Basically they provide a concise way and expressive way to create lists based on some tables. As I said, let's suppose I want to create squares. Okay. So if I write it mathematically, I write like this. I'll say x square for all x, let's suppose belonging in the range, some range 0 to, let's suppose, 10. This is how I write it mathematically. You might have seen set theory like this. So I'll say x square such that for all x which belong to 0, 10. This is how I write it mathematically. So he was a mathematician. So what he did is he said, okay, let's keep the same syntax. Let's keep the same syntax. So if I want the squares of these numbers, what I can do is, so I'll write x square. So how I have to write in Python? X square. Okay, then I'll have to write for all. This is called for all. I'll write for x in. So for x belongs to this. So what I'll write is for x in a range of, let's suppose I want 10. So this is basically, it'll initialize a list. So don't you see exact match between these two things? How you write it in set theory and how you write it in Python. List comprehension is nothing but a concise way to just initialize these lists. He was a mathematician, so he did it. its own his own choice. If some biologist created a language, he might want to do it what I call like he will like the biology way, and this guy liked it the mathematical way. He said, okay, we'll create something if I want to it concise, and we'll write something like this. And this is the set theory notion, and this is the Pythonic notion, Pythonic way of doing it. Let's see how to initialize this list, how to use these list comprehensions. They become really useful. Let's bring this VS Code back again. Just save this file, creating a new file, test3.py. Okay, now let's suppose we want a list comprehension. So let's suppose I want squares of numbers. I'll write SQ. So what I can do is, again, I showed you the mathematical way of representing that. X square, so I'll write is x square, and then what I said is x square for x belongs to, you can just remember that syntax, for x square for x in range of 5. You see how easy it is. Now I'll print this SQ. Now you see the initial list 0, 1, 2, 0, 1, 4, 9 and 16. I just squared each of the numbers. I got squares of the numbers. Okay, this is called a list comprehension. It's very powerful tool, very powerful. So when you have to write most of the things, you will use this. You have to initialize a list. You don't want to write a loop and big loops and multiple lines. So what you can do, you can just use it like this. Okay, and sometimes you can write, let's suppose, even you can use different. I don't want to take the names right now because probably it'll make you more confused, because I don't expect you to have coded much in Python. So I just want you to understand this concept. So list comprehension, if you see, is just a concise way of initializing these things. And if you want to initialize a list like this, so that's what it's called list comprehension, because it works for the lists. Okay. So even you can just change it for the cubes, and now range, you can just change the range. And these things are basically, you can vary these things, and these are things are list comprehensions. Any questions about list comprehensions? Just remember the syntax. What is the syntax? Remember the mathematical syntax, set theory syntax. So if I want to do anything, I say x square such that x for all x which belongs to some certain range, let's suppose 0 to 10, or which belongs to natural numbers, something like this. And that's what we have done in the Python. So for x square, we'll keep the same, and then for all, we'll write for in, and for this belongs to, we'll write range, or whatever you want to do. And you can have an iterable also in there. I hope this is clear. Okay, now there is another important thing. Again, today we have been talking about cryptography. Let's maybe end today's session with another note of cryptography. Let's suppose, yes, let's do it anyways. Let's suppose you want to perform a brute force attack. So let me define brute force for everyone. So you now know that if you have this phone locked with pin, okay, you have this pin and 4-digit pin probably. So you have a 4-digit pin by which you lock your phone. So that is by 1, 2, 3, 4, 5, 6, 7, 8, 9 and 0. Okay, these are the 10 numbers via which you lock the pin, and you have, let's suppose, 4-digit pins. And let's say you do not know the pin. Okay, you do not know. But what you want to check all the combinations, all the possible, what we basically call as permutations. I want to check all of these things. I want to say, I know that this is a 4-digit pin. So this is 4-digit pin. So each of this value can take 10 values. So how many possible values how many possible values for the pin can be? It can be 10 to the power 4. So these, if you want to generate all of these together, you can again use by loops. Okay, you can again use the loops to generate all of them. This is called as brute force attack. Brute force attack. Now we know the reason why people sometimes basically block the pin after 3 attempts, because they know you can just write a program, write all these basic what are called permutations. You can write all these permutations. If you write all these permutations, you can check each permutation. Let's suppose it takes, say, 1 millisecond. If it takes 1 millisecond, let's 10 to the power minus 3 seconds, and these are the combinations, 10 to the power 4. Okay, so how many? So this is the time required. So 10 to the power 4 multiplied by 10 to the power 3. So it will probably take 10 seconds. Something like this. Okay, and this is the value. If it's milliseconds, these number of milliseconds. Okay, these number of milliseconds. Let's suppose this much compute power, this much time it will take to break this 4-digit pin. That's the reason they have now introduced. Okay, how should the password at least have the length of 8 digits? So what they can do is 1, 2, 3, 4, 5, 6, 7, 8. Now they are saying that you should at least have a capital letter. You should put a capital letter in there. So caps letter, and then you should have a symbol, and you should have a number. So what it basically does it, and your password length should at least be, let's suppose, 8. So what it does is, now caps letters are 26, and small case letters are 26. Symbols, let's suppose, are 11, and numbers, let's suppose, are 10. So this is 6, 6. This is 12 and 13, 3, and this is 2, 6, 7. This is 73 possibilities. So for this 8, this is 73 to the power 8. So these number of possibilities, and if it takes now millisecond, so what it will do is it will probably take a lifetime, at least a lifetime, to break that password by brute force. Okay, and now on top of that, what they have done is all of these are software hacks. I told you all of these are software hacks. Okay, this number of if it's, let's suppose each of them takes a millisecond, the millisecond is down to about 3 seconds. Okay, so this is rather 10 seconds. For a 4-digit pin to break, if it takes for one password to just check, it will take 1 millisecond. So it will take 10 seconds. So here it is 73 power 8 multiplied by 10 to the minus 3. It will be again probably a lifetime, more than a lifetime. Okay, now what you are doing is when you put these crypto things in place, so you are just buying time. You are buying time from the brute force. You don't want to do this brute force, but there are clever ways to also like truncate down these things, and this is called as search space. So your search space is so big. Okay, your search space is big, and now at least let's suppose it will take 2 lifetimes. It will take 200 years, say. But I'm not saying this is not possible to break. And then what they do is they basically in the middle, what they'll do is if you have 5 passwords, then they'll say, okay, you have to wait for 10 minutes. Okay, if you again do it for 5 more times, and the password, now you'll have to wait, let's suppose, for 100 minutes, and they'll keep on doing it, so that they buy more and more time. Otherwise, if you have a password, you can easily brute force it. Okay, now Python provides you a way. Okay, now let's learn how to break that way. And that's why even iPhone people, they removed the jack. They removed the jack because you can just connect a jack and write a program, and which just checks all the possibilities. And many people were saying that why is the jack removed? Let me tell you the interesting stories. This is how the tech people should think. So let's suppose you have this. This is your, and you know, for charging port, it's really easy. You can separate out the charging port from the main circuitry board, because charging, the main point of charging is to charge the battery. You can have a circuit, different circuit. You have a circuit over here, and you have a battery over here, and this circuit is only for the charging, and you can just separate out it from the main CPU. But if you have this earphone jack, so earphone jack, you have to somehow connect it to the motherboard, or if it's a camera, you have to somehow connect it to the motherboard, because that's why the computation will be done. Because if you see the audio, it has to do multiplexing, demultiplexing, it has to change the electrical signals into these audio signals. So there is no way of escaping that. You should not have this circuit. If you have a physical connection now, this earphone jack, I'll write it earphone jack, pretty bad at handwriting. So earphone jack. So let's suppose we put an earphone jack over here. So this jack must have a connection with the motherboard. Why? Because I told you it will modulate, demodulate, and the CPU will be used. So what people can do is, now you know that I have access to these physical circuits. Okay, I can plug an earphone jack over here which has that connector. But outside I won't connect the earphone. I'll connect some machine, which will send some instructions. Okay, so I'm now getting access to basically the CPU, or basically the brain of the computer. So I can do anything. One rationale behind removing this earphone jack from Apple was to give more security, so that people, let's suppose if they got access to the physical access to a device, they can plug in the earphone. But I said, why can't they remove the charge? Why is it easy to deal the charging? Because charging has to do things with the battery. Okay, they'll just charge the battery, and it's a separate circuit. But this earphone, it's very difficult to separate the circuit out. And now even they are now trying to separate the audio circuit also. Okay, have very less connectivity with this CPU, so that people write the code, it won't go through. And all of these are software hacks. Okay. Now again, I'm digressing too much. So coming back to the topic, coming back to the loops. So what the Python gives you basically is, there is something called as itertools. ITERTOOLS. Okay, you can basically try all the combinations. Let's suppose the combinations that you know is this. Let me bring up the VS Code. Hope it is clear. So what I can do is, I'll just comment out this first, and then. So there is something called itertool. It's again a library. So it contains these permutations and combinations. So what I can do is, I can just provide from itertools import permutations. So now I know that numbers. If you are keeping, I'll call them, let's suppose, letters. Okay, and then I'll make it a list, and I want numbers. So I again use list of comprehension. X for X in range 0 to 10. Okay, let's first make sure that this is what I want. Okay, I'll just keep letters. So now if you see 0, 1, 2, 3, 4, 5, 6, 9, because these are all the and now I know that I want some permutations, all of these things. I want these, let's suppose it's a 10-digit password or something. If I want a 4-digit password, I can use it accordingly. Okay, so let's do this. So what I can do is, I can create permutations of this. I'll just show you the simple way of the permutations is equal to, and now I'll use this permutations of these letters. Okay, and this will basically give me 10. And now I'll say for p in permutations, prm permutations, print all of this. So rather better is just to initialize it with some 3 digits, let's suppose, so that it does not exceed much, because you know that there are a lot of possibilities. Now if you see this, if I run this program, oh, I should rather print p, not permutations. Now you see this, the possible combinations are 0 1 2 0 1 2 0 2 1 1 0 2 1 2 0 2 0 1, and this I just enumerate all the possibilities, which is just with the letters 0 1 and 2. Okay, so all of this thing, this is the permutation, and there are a lot of things, there are combinations also. Now you can print a lot of combinations also. Okay, I'll just show the example of combinations. This is from the iter tools. You just have to import this thing, just from iter tools import this permutations and combinations. Let's now check the combinations also. You have on different combinations. This is also helpful in mathematics. Okay, let's suppose I have this red, green, and suppose blue t-shirts. Now the color combinations I want is the color two combinations at a time. Now let's do this. So if you have this Python test.3, you can see you can have red, green, red, blue, green, blue. And here, if I want to check the password also, so I can say combination with, say I'll say numbers. Just want to show how to break password number, and then I'll use x for x in range of 10. Let's try it anyways, because maybe I know it will take a lot of time, but it's all right. So this colors, I'll take this number over here, and this colors probably, and I know that pin is a 4-digit thing, so I want 4 combinations. Now if I run this, now you see this is it hardly took a second. It hardly took a second to make all the passwords. See how fast I can break the things. You see, it hardly took a second, and it is a huge list. If you see it, start with 0 and then start with 1, and not more possible. And you can print how many possibilities are there. So I can just keep a counter. So counter is equal to 0 initially, and then keep on incrementing the counter. I basically want to see how many combinations are we checking, and then at the end I'll just print it. Print counter. Okay. Just clean the screen. And you see this is 210 possible combinations, but there should be more than that. I don't know what happens, because we are just checking for the combinations. We are not checking for the permutations. Combinations is basically, so this 1 2 3 4, if I write, let's suppose 1 2 3 4 4 3 2 1, this is same combination. The permutation is different. This is one combination, this is, and this is the same combination, but the permutations are different. They are permuted differently. So I can just use a permutation in instead of this combination over here. Let's do that also. Let's see if I can permute the whole things. I don't know if the syntax is right. I'm just look at this. This is 5040. These many permutations basically. Now I just messed the code, but it's all right. You got the gist. So how to do that? You can just use the iter tools, and you can just read the documentation. There are permutations. There are these combinations allowed for all these things, and you can just keep. You can permute the things. You can combine these things differently, and this is very much useful also in mathematics, not just in the password breaking. Any questions? Any questions for this? Any questions? I have a lot to discuss again. There is a lot of things that I want. I probably will take, if everybody is okay, I'll just take a couple of minutes. I'll take 5 minutes or 5 to 10 minutes more. I'll just cover these advanced methods so that we're done with this, and then we'll have an assignment on this, and then we can move on to next concepts like functions and this object-oriented programming, except handling, and things like that. Just give me probably 5 to 10 minutes, not more than that. Okay. Now I showed you different ways. I showed you these iter tools. I showed you zip, enumerate, and then there are also things. There are things like what's called the item method. Okay, so these item methods in Python, they are basically used with dictionaries to return the view of all items. Okay, so what I mean by the view basically is not a copy. It will just view it. If you change the things, it will just get changed in the view. It won't get changed in the original file. Okay, that's called as item methods. Items method basically. I would love to show it in the code so that you also get to know these things better. So just saving this file again, and running this 4th file. Today we wrote a lot of files. So now I'll paste the code over here. I'll just show you the VS Code. So if you see it over here now, so I have, let's suppose, a dictionary in which I have Alice and the grades of Alice. Let's suppose Alice got 85 numbers, Bob got 92, and Charlie got some 78 numbers. Now what I can do is I can use this items function, this items method rather. Okay, so by the help of that, if you see the enumerate, the enumerate was used if you have two separate files, two separate lists. But here, if you have a dictionary, you can use this items with the dictionary. Okay, what it'll do is, the first thing it'll do is it'll give you this name and it'll give you the grade. So basically, if you see, now you can use this items file with the items with the dictionary. Okay, so if I run it, it'll again perform with the zip. If as if I had two lists. Now you know that we have a dictionary. So I'll just run this code. So it should work as expected. Okay, now you see the Alice grade is 85, Bob's grade is 90, Charlie's grade is 78. Okay, and this items method, and I'm again telling you, it returns a view. Okay, a review basically is, it will not just have the original copy, it will just create a view of that, and you please search about what a view is. Okay, this is one of the functionalities. Now we'll study some of the function. This items method is one of the function, and the function is sorted. If you want to sort something, okay, Python gives you sort. Okay, Python gives you a function called sorted. Let's suppose you have a number, you want to sort them. Okay, let's say you have numbers and you want to sort them. We have a function called sorted. Just write it over here. We have a function sorted. So in this, what you can do is, so you can sort the things by just using this function. Say we have these numbers, we have a list of numbers 42719. So what I can do is, I can just call this sorted on this numbers array. So we will sort this array. Okay, now we can print the whole of this list and you will get. So if I just print this, if I run this program, so this is Python test.4, and I want to comment out this code. So the original list was this numbers, then we had the sorted numbers. So we want to print the list, so we have this original 42719, this was the original list, and now you got the sorted list. Okay, and I also wrote this for it. This is not even necessary for in sorted numbers, so I can just sort it on the fly. Okay, and this will return me that, and then I'll sort. If you see this 1 2 3 4 5, this is again sorted, but I'm just printing it one by one, so this is not required at all. This loop is not required at all. If you see, this is the original list 42719, and this again creates a view. Okay, that's why I have to store this. If I just create sorted, okay, if I just set sorted of numbers, okay, if I just create sorted, now if I print these numbers, so numbers won't get changed. So if you see, these numbers will not get changed. So numbers actually is original, the same thing. That's why I on purpose I assigned it. Okay, I made an assignment because this sorted function does not change the contents of the original list. Okay, if you see, this is sometimes we call them in place algorithms. This is out of place. Why is it out of place? Because it does nothing to the original list. The original list was numbers, so if you are printing them as numbers, they are intact. But once it sorts, it creates a view, temporary view, and if we assign that temporary view to actually some other variable, it will create a separate list. That's why I'm having these separate two lines. So you'll have to be careful again. Why am I showing you this example again? The point is that when you will write the code, sometimes you will write the function and you'll expect that the changes are happening in the original list, or maybe original variable, but the change won't happen there. You will have to be sure that the changes you are making are happening in the original. Okay, otherwise you'll have to assign after you call these functions. You'll have to assign like this. Okay, if I assign this to numbers, then numbers will get changed. So if I just assign it to numbers, just numbers, so I'll have this. Now I'm also changing the original list because now I don't need sorted. If you see, the list got changed. Okay, because I overwrote the list. But one thing should be clear. So when you are coding, you make sure that if you want the change to happen in the original list, and you must know that if this is just providing me with a view, or if this is making the change in the original content, you have to be sure about that. So this is one of the functions, sorted. So here if you see, this is the original list and this was the sorted list. Okay, because sorting is heavily used when you sort these things, and in C++, maybe C you have to write the sorting algorithm, but here you have just a function sorted, and probably now C++ has these collections, you can just write dot sort and it also gets sorted. And now also one more operation that probably you might need with these loops is sometimes you might need to reverse a thing. Okay, if you want to reverse a thing, so what you can do is there is a function called as reversed. Just pasting that so that you know all of this stuff in Python. So here if you see that if there is a message, this hello, it's a message, let's say it's a string. So now what I can do is I can say for character in reverse string message. So I can reverse each of this and I can print the character. So if I just print it, you can see whole of this thing got reversed if you see it over here. So this again is a functionality reversed, and there are a lot more things to discuss. Okay, there are a lot more functionalities, lot more things to discuss with the loops. Okay, why am I showing you this with the loops? Because now the question should be, this reversed will just give me the view. Okay, it will give me the view. It's not the original. It will not store the contents in some variable. Okay, for that I have to run the loop through. Otherwise, I'll have to assign it to something. Okay, I'll have to assign it, then I can print that. If I did it like this, I'll say reverse message. Okay, so I don't need this loop even. If I don't, I can write it without the loops. So I can just print this. Say print reversed. But you know, this is just a view. It's not stored in some variable. So you can see this. This is a reversed object. So if I want to get access of the object, I'll have to write each the element. Let's suppose I'll write 0. Say I'll see if it works that way. It does not work with this because it's a separate object. I'm rushing through, but here if you see this reverse, and there you don't need to import any libraries for these, and these are basically inbuilt in Python. Okay, you can just assign it to some other variable that I wanted to show. This is, let's suppose, rev, and maybe you can, again, it'll show me the same problem. I know, so it's not necessary to do it right here. So you can use this reverse with the lists. Okay, so now here we conclude the discussion of the loops. There are a lot of things to discuss, but I just gave you some advanced tools by which are there in Python, and by the help of which you can ease out your way basically of coding and ease of programming. You can take the advantage of. That's why it's called a Pythonic way. It's called a Pythonic way of doing things. What I mean a Pythonic way. So there's a specific way. You can either do it in C++, and there is a huge lines of code you have to write. But if I, let's suppose, tell you to reverse, so if you sort of started writing the code from the scratch, so that won't be Pythonic way. So Pythonic way just uses reverse functions and the sorted function. There are a lot more functionalities. I just wanted to show that these things do exist. So you have to go on the documentation to know more about these functions and read. If you want to use something, you can just read the documentation and get to know all these stuff. And now here I'll conclude the discussion on the loops. So if you have any questions, I'm willing to take the questions right now. I'll stop the recording.